Hello, we're in the process of switching functions from standard form into vertex form. And the key to this process is a process called completing the square. So what follows is an example of how we can take a quadratic expression and find an appropriate constant to add to the quadratic expression that turns it into a perfect square. And here's what we learned in class. If this is negative 18, all I have to do is find the two numbers that add up to negative 18 that are the same. In other words, I take half of negative 18, it gives me my two factors. If I was to multiply them together, I get 81, and so if I chose 81 to add, then I created a factorable expression where the two factors are identical, and hence I create a perfect square. So over on the right-hand side, I take half of 40, it gives me two 20s, square that, you get 400, creates a perfect square. So what follows are four other examples. We'll pause it to get when we get to the last one with fractions. Notice here, when I take half of 5, instead of saying 2 1/2, I say 5 halves. It makes the work a lot easier to square. And when I add 25 fourths, it makes it easier to factor. Now in this case, I have to take half of 9 halves. And taking half of fractions is really the same as just multiplying the denominator by 2. So here are some examples. Half of 3/4 is 3/8, that's just doubling the denominator. Half of 5/7 is 5/14, I just doubled the denominator. Half of 7/3 is 7/6. So we need two numbers that add up to get to 9 halves, the same number, negative 9 fourths and negative 9 fourths. When I multiply them together, I get 81 over 16. So right here I'm going to add 81 over 16, which creates a perfect square. And in the process I noticed that whatever my two factors are, that's going to be the opposite of the axis of symmetry in each case. So utilizing this technique, I can examine this quadratic function, and I want to create a perfect square out of it. The 4 is getting in the way, so what I'm going to do is I'm going to kick out the 4 and make way for a number, and to find that number I take the negative 10, break it into two equal parts, multiply those two parts together, and that number 25 is what I'll add to the equation. But I have to remember, if I add 25, take away 25, to keep the balance. What I've done now is created a perfect square right here in the middle. If I factor it, now I get a new form. So in the process, what I've just done is gone from standard form. By completing the square, I now have vertex form. So here I can find the y-intercept. This will tell me the axis of symmetry is x equals 5. The vertex is 5, negative 21. And if I need to find the x-intercepts, I can use vertex form and inverses to get that too. So I now have all the tools I need to work with quadratic functions in standard form or vertex form. Now we just have to practice. Sometimes our b values are not even, so when we make our x box, we have to take half of 7. We keep it in improper fraction form so it's easier to work with. We add 49 fourths, we take away 49 fourths. This part is a perfect square. I factor, subtract, and again make the observation that I now have standard form converted into vertex form. Last example is when the b value is a fraction. We could still take half of a fraction as I described, and that means this is the number we're adding and subtracting, creating a perfect square, which is factored in just the same way as everything else. And we go from standard form to vertex form. Thanks for watching.